My name is Walt Vandergaard. I'm a software engineer at NVIDIA. I'm going to be talking about accelerating high-performance computing with GPU Direct. I'm going to talk a little about the technology, a little bit about GPU Direct RDMA, which is important with Mellanox, and a little bit about CUDA-aware MPI. So as I said, GPU Direct is a term that we've been using a lot. It involves a whole evolution of technology over the last couple of years. There's some optimizations we did initially, so you could share host buffers between CUDA driver and Mellanox driver. There's some acceleration we did for when you had multiple GPUs on a node. And then lastly, which is coming up most recently, is GPU Direct RDMA. And that's what we've been working with Mellanox on. So the first evolution that happened around 2 years ago is way in the beginning you couldn't even share memory buffers between a CUDA driver and a Mellanox driver. So if you wanted to move any memory, you had to copy it into a buffer, copy it again, and copy it out, which obviously is a lot of copies, too many copies. So the first stage was simply making it that you could actually register memory with both the CUDA driver and the Mellanox driver. Next along the way, our next technology was optimizing peer-to-peer. So this is within a node when you have multiple GPUs. Again, initially if you wanted to move data between two GPUs within a node, we'd stage it in host memory first. But obviously that's not the optimal way to do it. So as of CUDA 4.0 and later, you can actually move the memory directly between GPUs. There's some limitations. You have to be aware of the topology of your node. If you happen to have a NUMA node, the peer-to-peer protocol doesn't work across the QPI interconnect, and there's other cases as well. So when running an application, you should be aware of that. Again, the peer-to-peer, there's a couple of ways to take advantage of it. If you happen to have a process that has multiple GPUs running within the process, then these are some of the APIs to check whether you can access your peer. If you can enable your peer access, and at that point you can simply do a mem copy and move data from one GPU to the other, completely not involving host memory at all. So another part of the peer-to-peer is actually if you have multiple processes on a node. In that case, you actually separate processes, each with their own GPU. You can actually use these various APIs, you can exchange these memory handles, and then again, two separate processes with their own GPU, you can now do a mem copy and move the data directly from memory to memory, skipping any host memory. So this brings us to the last piece of the GPU Direct technology. This is the most important one. This is why we've been working with Mellanox. So this is GPU Direct RDMA, and this allows third-party PCIe devices to access GPU memory. This is something that's available on Tesla and Hydro products. They have to be Kepler-class hardware and with CUDA 5 related. There's no hardware or firmware changes needed in the network interface card. However, you do need the device driver support. So to take advantage of it, work has to be done in the device driver. So just a little picture. This shows two of the GPU Direct technologies. You can see when you're two GPUs within a node, the data is going straight from memory to memory. You can see GPU Direct RDMA, moving it from one node to the other. No involvement in the system memory. So you get better latency, you get a better bandwidth. So what we're doing right now, so NVIDIA's been working with Mellanox, and we've been working to try to bring the support to some of the latest Mellanox drivers. If you want more specifics of which ones have it and what they have, you can talk to the folks in this booth. NVIDIA, we're also doing work with respect to CUDA 6.0. So we have an early access that's available right now. We've done some work down at the driver level. We've also made slight modifications in some of the API to make this all work properly. And if this is something you want to take advantage of, you can either do it through the verbs interface, where you can make use of a CUDA-aware MPI. And just to show, it's not all that complicated when you want to take advantage of it. So here we just show a little snippet of a code. You can see here that we just do a CUDA malloc, which gives us a buffer on the GPU. You can then register it with the Mellanox driver or the verbs layer, and now you can do an RDMA access and from underneath the covers, the data moves. So from an application standpoint, this is a really nice feature to have. I want to talk a little bit about GPU-aware MPI. So maybe you've heard of it, but the whole point with GPU-aware MPI is that you don't need to stage the GPU memory, the GPU data in host memory. You can simply call MPI APIs and hand in a GPU buffer. So you can see if you have a non-CUDA-aware MPI, you have to move it into a host buffer and transfer it. Here you can just do a send and a receive of the buffer directly. And what's great about this is a way that you can take advantage of all the GPU direct technologies that I was talking about. The MPI library itself can select the best way to move the data, much like it decides how to move host data. You can use the interprocess peer-to-peer communication if you're on a node. We can use GPU direct RDMA if you want to go off node. So a little more about GPU-aware libraries. There's a couple that are available out there. There's a Vapage, and right around the corner here, they got a demo going showing all of this. So they're a great thing. If you want to get more details, find out more about how this is working, you can go over there. There's OpenMPI, that's what I work on. I actually contribute to that code base, and I'm involved in that. And lastly, even IBM Platform MPI. They've been doing work as well to add the aware support in there. And I didn't show any specific releases of it. It's been evolving. Again, as some of the GPU direct technology evolves, these libraries can evolve with it, taking advantage of those various technologies and getting the best performance. This is a little graph we took. Again, this is a Vapage. They're right around the corner. It just shows some of the improvement we can get with this GPU direct RDMA. So we were seeing latencies on the order of 19 microseconds. We can get them down to around 6. And those numbers, these are rough numbers depending on your platform, your Mellanox cards. These could go down or up a little. But it gives you an idea of the order of magnitude that we're seeing improvements. So there's some contacts here. Interestingly, I'm not listed anywhere, but there's a whole bunch of information on GPU Direct RDMA at the NVIDIA website where you can access it. Mellanox has a whole bunch of information on it as well. Again, if you're interested, talk to the guys in here. They can tell you what releases they have that have the information in it, how it's being phased in, when it's coming out. In our case, it's CUDA 6. We have early access. It's available. Full availability is coming out in a month or 2 or 3. And that's it. That was short. Do you have any questions?